Hi, everyone. I hope you guys are doing well. Can I just get an indication whether or not you guys are able to hear me? Okay, great. I'm seeing a few thumbs up. Thank you, thank you. I hope prelim preparations are going well and that you guys have actually been gaining some useful information from our sessions. Today, we will be doing analytical geometry. My name is Muranga Dao. I'm a student at the University of Pretoria, and I currently study industrial engineering. So let's get into it. While I set up, guys, do you mind just telling me how we're feeling about the upcoming prelim exams? Which sessions you guys have enjoyed in particular? What more do you want to hear from us or see from us? And yeah, some people are saying that they're nervous. They're asking for more calculus. I think calculus is on Wednesday, if I'm correct. So please do be sure to follow our socials. We do post when we do the content and on which specific days. And it's literally to your benefit, guys. Also, if you know anybody that might find these sessions useful and informative, please share them the link. Don't gatekeep. We need to make sure that as much of us perform as best as we can. So, yeah. But, anyways, guys, thank you for joining. I will be setting up shortly and we can jump straight into it. Quickly, can you just guys say out of 10, just drop a number out of 10, just to see where we're sitting at when it comes to analytical geometry. Okay, some are saying 7, others are saying 10 out of 10, some are saying 5. Okay, hopefully by the end of the session, we will be at a number higher than what we started off with. So I hope you guys have your writing instruments, your calculators, and everything ready, and we'll get started. Just give me a second to quickly get ready. Alrighty, I am sharing my screen. Can you guys quickly just confirm that you're able to see what exactly is on the screen, please? Okay, great. Again, my name is Muranga Dao. It's a pleasure to be able to assist you guys with this in particular. And I'm hoping you guys have a willing and ready mindset going into this. Please be free to follow us on our socials at, let me write that properly, at the Learning Space ZA. Alrighty. We do also record these sessions and upload them to YouTube. So if you miss anything or would like to just revise it, you can check it out on our YouTube handle, which is also the Learning Space ZA. Like I mentioned, today we will be doing analytical geometry. And we're going to start off by doing a bit of revision on straight line geometry, and then we'll jump into equations of a circle. And then from then, we will do practice problems. So let's get into it. We're going to start off by revising straight line equations. Um, Firstly, over here, I've just gathered some formulas that would be useful for us to know. We have the theorem of Pythagoras. We use that to find the length of a hypotenuse of a right angle triangle. We have the distance formula. used to find the distance between any 2 points on the Cartesian plane. We have the gradient formula. We have the midpoint of a line formula. And we just have points on a straight line. Points on a straight line will always have the same gradient, once that they are on the same straight line. We also have different ways of representing the equations. We have, my apologies, we have the 2-point form, we have the gradient point form, and we have the gradient intercept form. You guys are most likely comfortable or used to working with this formula over here, if I'm correct. So yeah, guys, if you have any questions, please post them in the Q&A section, and I'll make every effort to answer them as soon as I can. Or if you see questions that you can answer for your fellow attendees, please do so. Right. When it comes to straight line equations, guys, we also have the following. We have information on parallel lines. They have the same gradient, and they make the same angle with the horizontal x-axis. Over here, we also have just the definition of angles. We have an acute angle, which is between 0 and 90 degrees, and we have an obtuse angle, which is between 90 degrees and 180. We also have to note that perpendicular lines, if you take the product of the gradient of the two lines, that will be -1. Okay, cool. With all this revision that we briefly did, let's jump into actually working out and using this information. I'll just give you guys a few moments to maybe screenshot these images if you'd like to do so, and we can jump straight into this. So please take a screenshot of this page. I'll go back to the prior page, and you can take a screenshot of that as well if you'd like. And we can actually get started with our first example of this session. This is the previous page, like I said, and I'm just giving you guys a bit of time to take screenshots of this if you'd like. If everybody's ready, can I get a thumbs up and indication in the chat, and we can get started. Okay, I'm seeing some thumbs up. I'm seeing indications that we're ready to get started. So let's do so. All right, we have our first question over here. In the diagram below, point D, which has the coordinates of 4, 5, 4x, 5y, and point R has -2x and 2y. T and S form a quadrilateral with point D and R. RD cuts the y-axis at N, and T is a point on the y-axis. The inclinations of RT and TS are alpha and theta, respectively. RD is parallel to TS, and the equation of TS is y is equal to a half x minus 2. Before we get started on 3.1, I just want to quickly ask, when it says that RD is parallel to TS, what does that mean about the gradients, guys? Yeah, it's the same gradient, so they will have the same m value when it comes to y is equals to mx plus c formula for a straight line equation. Cool. Question 3.1 asks us to find the coordinates of point T. What would those coordinates be? Can you guys post your answers in the chat, please? Yeah. So well done, Sharon. The coordinates of point T are 0, -2. And that is because T is the y-intercept of the TS line. And so in order to find the y-intercept, we set x to be 0, and we then end up with the following, which just simplifies to be -2, and this would be our coordinate for the y-intercept. So yeah, well done to everybody that got that correct. I'm going to erase this and make space for 3.2.1. We want to find the gradient of RT. What do you guys think that is? Or which way do you think we'd find it? The gradient of RT? Is there a formula that we can use, or is there a method for working that out? If you know the method, please do so and post your answer in chat so we can just compare answers when we go over this. So yeah, we do have some answers in the chat. We use the change in y over the change in x. That is the gradient formula. M is equals to y2 minus y1 over x2 minus x1. For this formula, we will substitute in the point R and the point T that we found in the prior question. Let's substitute that in. Let's make y2 and x2 point R. We then end up with -2 minus -2. Oh, we have 2 -2. There we go. My apologies. And for the x, we then end up with -2 minus 0, which then simplifies to be 4 over -2, which is -2. There's a question in chat. Somebody asked, how did we find the coordinates of t? We found the coordinates of t by finding the y-intercept of the equation they gave us. They gave us y is equals to half x minus 2, and that's for line TS, which is this one that I'm highlighting right now. So hopefully that answers your question. Yeah, the gradient is -2. Yes. Cool. If there aren't any questions on that, hopefully we can move on. Somebody asked, where did the positive 2 come from? I'm going to switch highlighter colors and show you where that comes from. So this positive 2 here comes from that over there, the y value of point R. The coordinates of point R are given as -2x, 2y, and so we take the 2 from the R coordinate and we put that in first. And from that, we subtract -2, and we know two negatives cancel out, and that creates a positive, and that's how we end up with 4 in the numerator. For the denominator, it's -2. That -2, I'm going to change highlighter colors. This -2 over here comes from that right there. And just like I explained before, the other point, let me use red, this over there comes from the coordinates of point T. Hopefully that clears up any questions that you had. So if everybody is happy and on board with this, let's move on to question 3.2.2. We want to find the size of RTS, the angle RTS. So let me just switch colors here and indicate which angle we're looking for in this case. We're looking for RTS, which is that right there. Cool. Do you guys have an idea as to how we'd approach this one? All right. If you guys have ideas on how we'd approach this one, please post them in the chat. Cool. Somebody said we use the gradients, and they mentioned something about parallel lines. We multiply the gradients to see what's going on. We were told that this is a quadrilateral, sure, and we have to use that information in the answer. What we're actually looking for, or what we would use for this one, is tan theta is equals to a half, which is the gradient in our case. So let's get to actually solving this. I'm going to do it where there's space. So firstly, we're going to start off by finding tan, or we're just going to start off by finding the magnitude of theta. And that's because in order to find RTS, we have to imagine a straight horizontal line. We know that this over here is theta, whereas angle alpha would be from the horizontal line all the way there. And so to find RTS, it would essentially be alpha minus theta. Are you guys able to hear me clearly? Somebody said I should raise my voice. Perhaps try increasing the volume on your side. But I'll just go over it one more time. In order to find angle RTS, we have to imagine a horizontal line at point T. And from there, we can see clearly that RTS would be angle alpha, which is from the horizontal all the way up until the line, minus angle theta. So let's get to actually solving this. Let's start off by getting theta. We know that tan theta is equal to a half. This half comes from the gradient of the equation that we were given. The equation is y is equals to half x minus 2. And so if we get the value of theta, we end up with 26,57 degrees. Cool. Now let's move on to finding the value of alpha. We're going to take the same approach. Tan alpha is equals to minus 2. But some of you guys might be asking, where does this minus 2 come from? This minus 2 comes from the gradient of RT that we calculated in 3.2.1. Somebody asked, why are we using the half? The half over here, I'm going to highlight it in green. This half over there is the gradient of the equation given here. That half is m, so it's the gradient value. So yeah, let's get back into it. If we get the value of alpha, alpha in our case will be 116,57 degrees. And we have to bear in mind that alpha is an obtuse angle. So because it's obtuse, when we calculate it, some of you guys might find a value that is different. But in our case, we need to make sure it's obtuse. So we end up with 116,57 degrees. Cool. Now that we have alpha and theta, we can get angle RTS, which is going to be alpha minus theta. So let's actually get to calculating that. We have RTS is equals to 116.57 degrees minus 26.57 degrees, and that'll then give us a value of 90 degrees. So now we've calculated that the size of angle RTS, I'm going to write it down here, RTS is equals to 90 degrees. Cool. I'm just going to add that to our diagram. Great. Let's continue on. We want to now determine the equation of RD in the form of y is equals to mx plus c. And so for that, while we already know that RD has the same tangent as TS. Okay, we have another question. Let me just answer the questions in chat. It seems as though some of you aren't able to see how we got alpha, so I'll gladly explain again. Alpha is the angle from the horizontal all the way up until there. And so in order to find the value of that, you're going to have to use the gradient of that line. The gradient of line RT is -2. And so we set up the equation tan alpha is equals to -2. If we solve for alpha, we then end up with a value of, if you actually solve for alpha, we actually get a value of alpha is equals to -63.43 if you put that into the calculator. But we have to bear in mind that alpha in our case is an obtuse angle. It is indicated as such by the question, and we can just see alpha is on this side, and because alpha is obtuse, it's going to have to be 180 degrees minus 63. That -63 is actually saying that it's 63.43 degrees if you go from the left all the way there. This side here is a 63.43 degrees, and that's a negative because this one would be clockwise. Positive angles in our case are anti-clockwise, are in the anti-clockwise direction. So hopefully that clears up a bit of confusion. So yeah, just to clarify again, we want alpha, which is in the anti-clockwise direction from, I'm just going to use a highlighter, from here to there. And we know this angle that I'm highlighting over there is going to be 180 degrees minus this pink one that I'm going to show you over there. And so that's how we got alpha. Hopefully that clears up any confusion or questions that you guys had. And we can get to question 3.3. Can I just get indications in the chat whether or not we're all on the same page, if you're happy with what we just covered? Cool. Somebody has another question. Couldn't you multiply a half and -2 because it's -1 and say the angle is equal to 90 degrees? Yes, we could do that. That is another way of working it out. Well done on spotting it. So I'm just going to write down that other method of working out so everybody else can see what Lilita is referring to. The other method of working out angle RTS would be as follows. The gradient of TS is a half. We are given that by the equation. And so we also know, or we figured out in the prior question, that the gradient of RT is minus 2. And because the gradient of TS times the gradient of RT is equals to minus 1, we can therefore conclude that they are perpendicular. And if they're perpendicular, it goes to show that, or it just states that, the angle between the two lines is 90 degrees. So yeah, this is the other method on how we could get angle RTS. Okay? Are we all clear on that? Do you have any other questions? Can I get a thumbs up or maybe indication in chat? Okay, I'm just going to move on to the next one since I'm not seeing any other questions. So yeah, let's continue on. We want to now find Siatemba, when you say the recent step, what are you referring to? Are you referring to the second method? I'll just go over it once again. For the second method, I'm going to use my highlighters just to indicate. For the second method, we have both gradients of line RT and TS. The gradient of TS is given as half if you look at the equation, and the gradient of RT is calculated in question 3.2.1, which is -2. If we multiply the two gradients together, we get a value of -1. And what we do know about perpendicular lines is that when you multiply the gradients together, we do in fact get a value of -1. Therefore, we can say that angle RTS forms an angle of 90 degrees. Hopefully now we all 100% clear on that and we can get to the next question. Can I get a thumbs up or indication in chat as to how we're feeling about this now? Okay, so it seems as though everybody, or the majority of us, are on the same page. So we can now get to finding the equation of RD in the form y is equals to mx plus c. I see some of you have actually started with that, which is quite great to see, but I will just do the working out for those that haven't gotten the chance to do this. Please take a screenshot of what is on the screen because I'm about to erase it, or in actual fact, make it smaller so that I have space to do question 3.3. Just give me 1 second. Cool. The working out has just been made smaller so I can have space to do question 3.3. We want the equation of line RD. We know that the line RD has the same gradient as TS. So we can already jump and write y is equals to half x, no, sorry. Yeah, y is equals to half x plus c. Now we need to find the coordinate of c. We can do that by substituting any point that lies on the line RD. We could use 0.45 or we could use point -22. I'm going to use point -22. So let me just write down. I'm going to substitute -2 into equation 1. I'm just going to have this equation there as equation 1. If I substitute the points in, I have 2 is equals to a half times minus 2 plus c. This then leaves me with minus 1 plus c is equals to 2. And this simplifies to be c is equals to positive 3. If I rewrite the complete equation for the straight line, it's then going to be y is equals to a half x plus 3. So well done to everybody that was able to get this on their own. And if we have any questions on how this was done, please post them in the Q&A section. Otherwise, can we move on? Can I get a thumbs up or indication in the chat? Okay, great. It seems as though we're all set and ready to move on. So we will do so. We have another question here. And after this question, we're going to move on to doing equations of the circle. So let's get to it. I hope this, yeah. So we're going to be doing question 3.4 and 3.5 now. 3.4 states, if RT is parallel to DS, we need to calculate the coordinates of M, which is the midpoint of RS. I'm just going to draw a straight line between RS and just put a guess as to where point M would be. Point M would likely fall somewhere here, and we want to find the coordinate of that point. Do you guys have any ideas on how we would follow through with this one? Someone posted in chat, I can't see question 3.4. Yeah, I'm not too sure why you're unable to see it. I can see it from my laptop, which I'm also presenting to you, so that I can read your questions. So maybe check if it's not a network issue. But let's continue on. We want the coordinates of M, which is the midpoint of RS. What can we use? Is there a formula that we can use? Yeah, so we have to find the coordinate of point S and then use the midpoint formula. That would be the approach for this one. So first of all, let me write that down. So for 3.4, we want to start off by finding S. And then we want to do use the midpoint formula. And so how would we find the point S? Do you guys have any ideas on how we'd find the point S? The y value of t was found in the prior question. We can use inspection. Yeah, well done on that, guys. So if we use inspection, we're just going to compare the points R and T, and then we'll apply that transformation, that's a good way to call it, to the points D and S. So let's get started. Point T we found previously. I'm just going to write down the coordinate of point T. T is 0 minus 2. Cool. Just going to draw the dotted line and show the difference in X and Y. So the difference along the X-axis is 2, whereas the difference along the Y-axis is 4. If we apply the same thing to points D and S. Along the y-axis, it's going to be 4, and along the x, it's going to be 2. So what would that look like when it comes to finding the actual coordinates of point S? It would be as follows. It would be, for the x, it's going to be 4 plus 2, whereas for the y, it's going to be 5 minus 4. It's because we're going 4 down. We then end up with a value of, or coordinate of, 6, 1. Right? So, cool. Now that we have the coordinate of S, let's get to using the midpoint formula. The midpoint formula is straightforward in that we get the difference between the two coordinates, or between the corresponding x and y coordinates, and we divide that by 2. If we use it, it's going to look like this. We're going to have 6 minus 2 over 2. And then for the y, it's going to be 1 plus 2 over 2, which then gives us a value or coordinate of 2 and 3 over 2. So that would be the coordinate of point M. There are questions in the chat asking, how did we get the S coordinate? We did it by inspection. So they told us that RDST forms a parallelogram. Cool. And because it forms a parallelogram, we can use inspection to find points of parallel lines for the parallelogram, right? In our case, we looked at point R and T because we have those coordinates. We're given point R in the question description, whereas we found point T previously in question 3.1. Cool. We started off by inspecting the difference in the y values of R and T. That gave us a value of 4. It's going to be 2 minus 2 would give us a vertical distance of 4 between the 2 points. And then we moved on to finding the distance between the x of the 2 points, and that is 2. We apply the same differences to points D and S. We know that the difference in the x values of the coordinates of D and S is going to be 2, and the difference between the y values of the coordinates D and S is going to be 4. So from then, we actually have to get the values of the coordinates. We got that by writing down over here. S is 4 plus 2 because you have to move 2 to the right to get from D to S. And then you're going to have to move 4 down to get to the actual coordinate. That's how we got the value of S. After that, we just use the midpoint formula to finish off and answer question 3.4 and get the coordinate of M. There are questions of whether or not there was another way of getting point S. Trying to think. You could have gotten, well, in actual fact, you could have found the answer to this question by getting the midpoint between D and T. We were told that it's a parallelogram, and because it's a parallelogram, the diagonals will intersect at point M. When it comes to finding the coordinate of S, I can only think of the one way. Well, there's the other way of finding the point. Actually, I can't even think of another way to find point S, but I think the most straightforward way would be to get the point S by inspection. We have another question asking, can you use the distance formula? But yeah, you can use the distance formula. It's going to be longer, but you just have to make sure that your maths actually checks out. Cool. Do we have any questions on this before we move on? Are we able to see how we got S, point S? Can I get a thumbs up or indication in chat, guys? Okay, some are saying yes. There is that one person who said no. Do you mind explaining where specifically or how specifically you it doesn't click with you so that we can make sure that we all 100%? Okay, I'm just going to continue. If we need to go over this again, please do check out our YouTube channel. This is where we post these sessions and many others for your guys' benefit. We're just going to move on to question 3.5. We want to get the area of triangle RTN. I'm going to highlight that and we will get into it. I just quickly want to write down neatly over here the coordinate of point N. Cool. We want RTN, this area that I'm highlighting over here. Cool. This would typically be a 4-mark question. We have 2 approaches to get it. Do you guys have any idea on how we can get RTN? Yeah, we could split up RTN into 2 triangles. That'll make it easier for us to actually find the areas. Or we could just do like the area rule. So for this one, what I will do is firstly, we need to get the coordinate of point N for the first method. So let's do so. We want to start off by finding N. The coordinates of N would be the y-intercept of RD, line RD. We did get the equation of line RD, which is y is equals to a half x plus 3. For the y-intercept, we set x to be 0, and we then end up with the value of y is equals to 3. So now we know that the coordinate of N is going to be 0, 3. Cool. Next, we want to find the, what can I say? The magnitudes of the lines Rn and RT. Rn is going to be the square root of 2 squared plus 1 squared, which is going to be root 5, whereas RT is going to be 2 squared plus 4 squared. which is root 20. Cool. To get the area, it's then going to be a half times the values that we just found. So it's going to be a half of root 5 times root 20, and this is then going to give us a value of 5 units. Cool. That was approach 1. We can get into approach 2. So I'm just going to make this smaller so I can have space to write down approach 2. Cool. For approach 2, we get the magnitude of line Tn. Tn is just 5 units. We get the difference of the y values. Because they share the same x value, we can just get the difference between the y values of the 2 points, which is going to be 3 minus minus 2, which is 5 units. From then, we have to find the height. The height is simply the x value of point R. And that's because, let me switch the pen color. From here to here is a value of 2, as indicated by the coordinates of R. Cool. From then, we can just use the area formula or rule, which is going to be a half times 5 times 2, which is 5 units squared. And yeah, those are the two methods on how to get the area of triangle RTN. Do we have any questions on this? Somebody asked, how do we know that Rn is our base? We just set it as such in our case. I need you to recall all the information that we covered for our parallelogram previously. We found out that, just switch pen colors, the angle RTS is 90 degrees. Cool. And because this is 90 degrees, we then gonna have 90 here as well. That's just how it's gonna be. And so from there, we can just set Rn as our base and use RT as our height. If we rotate the triangle so that it's easier for us to follow along with, it's then gonna look like this right here, where we have T, N, and R over there. This is just gonna be the 90 degrees, that angle, which is DRT. So yeah, we just chose Rn as our base for the first approach. For the second approach, we chose NT as our base. Cool. Somebody said elaborate on the area part. What specifically? Do you mind being more specific? Another person asked, may I try the other method? I have tried the other method. The other method is what I just covered, which is this one that I'm going to circle in red right here. For the other method or way of working it out, we took RT as our base. So maybe let me write that down so that it's easier to follow along with. For the first method, Rn is our base. For the second method, RT is the base. Cool. Somebody said we can cut RT and NTD and add their areas. Yes, you can cut RT and NTD. NTD. I'm not too sure what you mean by NTD, but you could cut the triangle and add the areas if that would be easier for you. But we also have to bear in mind that time is a factor that we always have to consider when answering our exams. So yeah, that's it for straight line equations for the moment. Do we have any questions before we move on to equations of a circle? If not, can I get a thumbs up or indication in the chat and we can move along? Okay, great, guys. Now that we're all on the same page, let's carry on. Moving on to equations of a circle, guys, I promise you there isn't much to remember or memorize in regards to this. It's essentially one equation, which is the equation of a circle, and we add on a little bit more information, which is shifting the center of the circle. Somebody quickly asked me to repeat question 3.4. Which one is 3.4? Okay, to be honest, I can circle back to it at the end of the session. I'll make note of it. For the moment, I just want to make sure that we are able to cover equations of a circle as well in the session. Our session will be posted on our YouTube, which is, I'm going to write it down for you guys. The Learning Space ZA. This handle is the same for Instagram and TikTok as well. So please be sure to check us out. Our sessions for all our prelim master classes and winter school and whatever else we have going on are always posted on our YouTube. So yeah, let's move on to equations of a circle. Like I mentioned, we essentially have a single equation, and from then we add on shifting it or shifting the center of the circle. We have the derivation or the method of finding the actual equation of a circle. It all comes from the Pythagoras theorem. And we end up with the equation that you guys know very well, which is this one right here. This is just the equation of a circle with the center at origin. Origin being the coordinates 0, 0. We also do have the equation of a circle with center at AB, which is the one that I'm going to highlight in green right here for you guys. This equation of a circle with center AB applies to origin as well. If you just substitute in the points 0, 0 in place of A and B, you end up with the blue formula. I was just showing you guys the link between that. Hopefully you guys found it interesting or just help you understand what's actually going on in regards to this equation in particular. Cool. Let's move on to actually doing questions and practicing this. This question reads as follows. In the diagram below, a circle centered at M with center PQ touches the axis at S. And the line OA is tangent to the circle at N, which is the point 6 minus 8. Question 4.1.1 asks us to find the length of ON. So for the length of ON, we just have to use the just the length formula. I don't know how else to say it, but yeah. I'm gonna give you guys maybe a minute or two just to try it out to make sure that you guys are on the same page and know how to find the length of a line. Please post your answers in the chat and we will check in just to see that we're all on the same page. While you guys are finding the answer, how's the pace so far? Am I moving too quick, too slow? Um, are there any changes or edits that I can make currently that would enhance the experience for you guys? Okay. One person said good pace. Uh, just perfect. Okay. Thank you to the ones who are answering. So I'll just continue on with this pace. Again, guys, if you have any questions, please post them in chat. If I don't see it, please make sure that you answer one another and help each other out. Cool. Let's actually get to finding the answer for 4.1.1. The length of ON. It is 10 units. Well done to everybody that got it correctly. Let's just put the working out down for those who weren't able to find it. ON is going to be the square root of the difference between the x and y coordinates of O and N, respectively. So it's going to be, in the first bracket, we have 6 minus 0 squared plus, I'm going to have here minus 8 minus 0 squared, which is going to be 100, the square root of 100, which is 10 units. 10 units, yeah. Let me just make space so that I can actually indicate the units. Cool. Now let's move on to 4.1.2. We want to find the value of P. How would we find P? How do you guys think we'd find P? Do you guys have any ideas on how we'd find the point P? Somebody said substitute into the formula. Which formula are you referring to? Do you mind explaining? Someone said tan perpendicular to radius. If I draw that in, let's see, will that help us in finding the value of P? Tan perpendicular to radius, yeah, we know that this angle there is going to be 90 degrees. Sure. But guys, this question would be a 2-mark question, to be honest with you. We can get the value of P quite quickly, and that would need us to remember our, I think it's called the tangents from the same point formula. If you have tangents from the same point, we know that ON is equals to OS, right? So let me write that down. Cool. And because ON is equals to OS, and we wrote tangents from the same point, we can therefore early jump and just write down the value of P as 10. Are you with me? Are you guys able to see why exactly or how exactly we can get the value of 10 for point P by using the tangents from the same point theorem? Okay. Tangents from the same point. The theorem will go as follows. So I'm just going to put in our radii. So we have the radii MN and MS. Cool. Now from there, if we had to apply the tangents from the same point theorem, we'll see that this here is 10 units and that there is going to be 10 units as well. And so for us to find point P in particular, let me just check. We'd, yeah, essentially just kind of rely on the information, guys, for that right there. Just trying to think of a way to explain this, maybe by, yeah, somebody posted in chat, P is equals to 10 since S lies on the x-axis and its coordinates are P0. So P will be 10. Yes, that is actually the best way to put it. I was just struggling to find the words. P will be 10 because S lies on the x-axis. And so this 90 degrees means that this line that I didn't draw like neatly, let me try and make it straight. This line right here is vertical. And because ON has a magnitude of 10, OS also has a magnitude of 10. And that's because of the tangents from the same point theorem. That is based off a congruency between the two triangles, OSM and ONM. Cool. And now because S is directly above M, you can therefore say that P would be 10 units. Hopefully that was a bit more of a straightforward answer that you guys could see and understand. Thank you, Lerato, for pointing that out. Somebody asked if I use the equation r squared is equals to x squared plus y squared formula and substitute in point n, will it be all right? In order for us to use that formula, we'd have to know our, we'd have to know the radius, of which we haven't been given at this point. And we don't have the complete equation for the circle in our case. Yeah, that method would take long because you'd first have to start off by finding the equation of a circle. Somebody's asked, can we assume line S is a tangent even if they don't say? Well, we were told that line S is a tangent because the question reads as follows. It says that in the diagram below, a circle centered at M with coordinates PQ touches the x-axis at S. That little statement there, touches the x-axis at S, means that it's tangent to the x-axis. Cool. Somebody asked, why did we say ON is equals to OS? We use the tangents from the same point theorem. Let me actually write that down. Cool. Are we all on the same page? Are we all 100% on this question? There were other methods to get the answer, but those would have been incredibly long. In our case, we could have just used the tangents from the same point in order to get point P, because conveniently, angle S, which is a second, or not angle S, line OS, which is a second tangent, is directly above point M, with S being like straight, directly above M. So yeah, hopefully this little explanation that we've done is clear to all of you guys. Can I get a thumbs up if we're all ready to move on to question 4.1.3? Okay, cool. It seems as though majority of us are on the same page, so we will move on now. Question 4.1.3 asks us to find the gradient of line NM. Cool. This would be a 3-mark question, and I'll give you guys a hint. We're gonna have to use the tangent perpendicular to radius theorem, or the information you get from that, in order to get the gradient NM. So I'm going to give you guys a few minutes to try it out. Please post your answers in the chat, and we'll just check in to make sure that everybody's on the same page. I see a few answers are rolling in. Let's just wait for a few more responses before we actually get to confirming whether or not you guys have actually calculated the correct answer. I'm getting a few more answers. Just want to wait for a few more people, and then we can actually get to getting the value of the gradient of NM. Okay, I'm seeing a mix of answers. I'm seeing 3/4, and I'm also seeing 4/3. Okay, now that a couple of you guys have answered, I will say that the correct answer for this question is in fact 3/4. Well done to everybody that got that correct. To those who got 4/3, there might be there might be a small point that you guys overlooked. So let's actually do the working out to see where you deviated from the answer. Cool. In our case, we can construct the radius mn to have mn perpendicular to OA, because OA is a tangent. You don't, for this question in particular, you wouldn't be penalized for not stating that you're constructing the radius mn, but it's good practice to state any constructions that will help you or have helped you in solving questions. So I'm just going to write it down. Construct a radius NN. And then in the following line, I'm just going to write ON perpendicular to NN. And my reason would be tangent perpendicular to radius. Cool. Now from then, we can actually get to finding the value. We're going to start off by getting the gradient of ON. We're going to use the gradient formula. M is equals to y2 minus y1 over x2 minus x1. Since O is the origin point with coordinates 0, 0, I'm just going to write down minus 8 divided by 6, and that'll give me a value of minus 4 over 3. This is going to be for line ON. So I'm actually going to erase that a little bit and specify it over here. MON. Cool. And now, because ON is perpendicular to NM, we know that the product of their gradients is going to be minus 1. So let's write that down. MON times MNM is going to be minus 1. We calculated MON, so we're just going to write minus 4 over 3 times MNM, the gradient of line NM, is equals to minus 1. And to solve for the actual gradient that we want in this question, it's going to be minus 1 divided by minus 4 over 3, which is going to be minus 1 times 3 over 4, which is going to be 3 over 4. Yeah, so it's minus 1 times minus 3 over 4, which is 3 over 4. So yeah, that's how we get the gradient of line NM. Cool. Are we all on the same page in regards to this question? Is there any confusion? How are we feeling about this? All right. We're on the same page. I'm seeing thumbs up. All righty. Somebody's asking, how did I get the Q? We haven't worked out the value of Q. We're still on 4.1.3. But if you'd like to work ahead, you're more than welcome to do so. Since we're on the same page in regards to this question, let's actually get to find the value of Q. I'm just going to make this smaller so I have space to do the working out. Cool. We want to find the value of Q now. And for this question, we're going to use the value that we got in 4.1.3, which is the gradient of NM. Let's get to it. We already know that point M is an incomplete coordinate. It's going to be 10 for X, and then the Q is going to be for the Y. It's an incomplete coordinate. We want to find what Q is. We can use the gradient of NM to do so. And I'll show you how. If you use the gradient formula, it's going to be y2 minus y1 over x2 minus x1, which is then going to be, if you substitute in our points, it's going to be q plus 8 over 10 minus 6. All right. And we know that this is going to be equal to 3/4. Remember, we calculated this in the previous question. From here, we can actually get to solving the value of q. We'll do so algebraically. We then end up with q plus 8/4 is equals to 3/4. Right. If we solve for q, we then end up with a value of -5. Yeah. Why is 8 positive? It's because we're subtracting -8 from q. I'm just going to do the substitution here to show you why exactly. It's going to be q minus -8 over 10 minus 6, which is then going to be q plus 8 over 10 minus 6. Hopefully that's clear to you now. And yeah, how are we feeling about this question, guys? Out of 10, are we 100%? Are you able to see how exactly we worked it out? Are there any questions on what we've just done? Okay. It seems as though of the ones that have answered, people are saying 100, 100. Some person said 95. So I'm just wondering what do we have to do to get to 100%? But otherwise, it seems as though we're on the same page for this question. Let's move on to the next one. Cool. We're going to continue on with 4.2 and 4.3. Now we actually have to determine the equation of the circle in the form, in brackets, x minus a squared plus, in other brackets, y minus b squared is equals to r squared. Cool. In order to do this, we first have to start off by finding r, which is our radius. How do you guys think we'd find that? How do we find the radius r? I'm just going to draw in the information that we added in the previous working out. Let me draw the right. Yeah, cool. So how do we find r, our radius? Somebody asked the distance between n m. Sure, you could use the distance between n m, but guys, r is an actual fact. Yeah, we could find the distance between n m or the distance between sm and go from there. But people are saying nm, so let's go with that one. We're going to use the distance formula. How would that now look like? Can somebody put in chat how exactly we'd find r? Yeah, if there is an alternate method, please go for it. But otherwise, if you guys are certain of the methods to find r, can I get answers in the chat? What do you guys think our radius of the circle is? Remember, guys, we found the coordinate of point M, right? M is 10 minus 5. Let me actually write it down here. Might be better or easier for you guys to see what I'm hinting at. Cool. We could get the distance between SM, and since we know that SM is directly above, since we know that S is directly above M, the distance between them is just the distance between their y's, which is going to be 0 minus 5. That gives us a value of 5. That is the distance between SM, and that is our radius. So that would be a quick way to get our radius. That's what I was trying to hint at. So I'm just going to write down for question 4.2, r is equals to 5. You get a single mark for working out r because it's straightforward to see if you just did it in the way in which I showed you. This question in its entirety would be 3 marks. Let's get to actually finding the equation of our circle with center AB, where AB is PQ respectively. So can you guys just type that up in the chat for me, please? So I can confirm whether or not you guys are on the same page with what we're doing thus far. Somebody just asked, how is R 5? R is 5 because that's the distance between S and M. S is directly above point M. We know that because S lies on the x-axis. And based off what we did in the previous questions, we can just confirm that S is directly above M. And now to find the distance between the points, we don't even have to use the distance formula. We can just see, or by inspection, if that's the correct way to say it, that the difference between S and M is simply 5. Minus 5 is the y coordinate of M, and it also just states the distance between the points or the y coordinates of S and M. Hopefully that was a bit clear or clearer to you now. Yeah, let's actually find the equation of the circle in the form given. It's going to be x minus 10 squared plus y, or in brackets y plus 5 squared, and that's going to be equals to 5 squared. You could have also written it as this. Cool. That's it for this question. Let's move on to the next one. In 4.3, it states x is equals to k is a tangent to the circle in the form, x is equals to k is a tangent to the circle. We have to write down the values of k. What would k be in our case? If we're given the equation x is equals to whatever number, we know that it's going to be a vertical line. And so the question now is, at which x values will we find tangents? This would be a 2-mark question. With the x values, guys, we're going to be looking at, I'm just going to draw a line here and here. We're looking for these 2 tangents. To find them quickly and easily, we could start off at the center and move 5 to the right, because that's the radius. We go 5 to the right, meaning that from 10, if you go 5 to the right, we get x is equals to 15 as the first one. So I'm just going to write that down. If we start at the center, one more time, and we go 5 to the left, we then end up with 5. So the 2 x values that we were looking for in this case are x is equals to 5 or x is equals to 15. Those are the answers for 4.3. Cool. Do we have any, oh, it should be k is equals to 5 or 15, which would be the same thing as writing x. Cool. Do we have any questions on 4.3? There isn't much working out for this one, to be honest. We just have to use our knowledge of the equation of circles and be able to arrive at the conclusion. Cool. I'm going to use a red pen just to explain one more time. Just going to erase this green highlighting that I did. Right. So we want to find the two x values at which we will have tangents, right? And if we given x is equals to whatever as an equation, we know that those are going to be vertical lines. Cool. The only two vertical tangents that we have for the circle are on the left and right side. Now we actually have to find the values of the x coordinates. We're going to start off at the center and we're going to move 5 units to the right. Move 5 units to the right. This then changes 10 minus 5 to 15 minus 5 because it is on the same x axis or x unit, x plane, if that's the correct way to word it. So the coordinate of this point over here that I'm circling in red would be 15 minus 5. We found that by simply moving 5 to the right. 5 is the radius, and you move 5 units to the right to arrive at that point. So we now know that this value over here is 15. Now we have to do the same thing, but going left. So we start again at the center and move 5 units directly to the left to arrive at this point right here on the left. The coordinates of this point will be 5 minus 5, but we're only interested in the x values of the coordinates because we want x is equals to k as the equation. We want to find the values or the possible values of k in our case. And that's how we arrive at 5 and 15 being the two possible values for k. All right? Are we clear on that for those who had any confusion surrounding this question? Can I get a thumbs up? How are we with this question? How are we with the questions that we've done thus far? Okay, cool. It seems as though we all have a better understanding. So let's move on to the next one. We're going to be doing 4.4 and 4.5. Quickly going to sketch the stuff that we added before because it might help us. Right. We're told that the line y is equals to negative 4 over 3x plus t cuts the circle at 2 different points. We have to determine the values of t. Before we start off, this minus 4 over 3 should ring a bell, right? This gradient, let me highlight it in orange. This gradient over there is a value that we've seen before in one of the prior questions. And that is ON, the gradient of ON right here. Cool. So now that we have that in mind, let's continue on. It says that minus 4 over 3x plus t cuts a circle at two different points. It's going to be a line parallel to ON. So it could be this right there. It could be that. It could be this. It could be all these lines that I'm sketching. Just imagine them being parallel to the line ON. Sometimes it helps to be able to visualize what exactly is being asked so you can actually get the answer. Cool. We have to determine the values of t now, right? So how do you guys think we'd go about actually solving for this? Do you guys have any ideas? Because for this question in particular, when it says determine the values, we're also looking for a range of values for t. So we're just going to get a range of values. How do you guys think we'd approach this one? For this question in particular, we know that if, I'm going to indicate it in red, if we move this line here, so imagine this line there being the equation of, actually, let me rather redraw it so I can move it and it's going to be easier for it to understand. Yeah. Cool. So imagine this line over here that I'm moving around as the line y is equals to minus 4 over 3x plus t. We don't know what the y-intercept is. And so it could be any line between here and right there because we're told that it intercepts or it cuts the circle at 2 points. So we know it has to be between this and that right there, all right? And so we essentially have to find that range of values. And so how do we translate this range that we're moving in here and use that for our actual answer, guys? That's what this question is essentially asking us. Hopefully this helped with the visualization. So let's get to actually solving for this question. Right. We're going to first off have to find the coordinate of the point directly opposite to n. So this one that I'm going to indicate for you guys right here. Let me actually do that in red. You have to find this coordinate directly opposite to n, right? Let's call this one coordinate C. Let's find that point. We know that C, to get that, we're going to need to do the following. We're going to have x plus 6 all over 2 is equals to 10. And we're also going to have y minus 8 over 2 is equals to minus 5. This right here is an adjusted or adapted midpoint formula that I'm using. Point M is the midpoint between N and C. That's what I need you guys to be able to see and realize. Right, let's carry on. If we solve for x, we then end up with x plus 6 over 2 is equals to 10. If we multiply both sides by 2, we end up with x plus 6 is equals to 20, and x is equals to 40. Cool. Let's find y now. I'm going to do the exact same method when it comes to finding y. Then I multiply both sides by 2, then end up with y minus 8 is equals to minus 10. If we take that negative 8 to the other side, we then end up with y is equals to negative 2. So now we have our coordinate for point C. 14 minus 2. Are we on the same page? Can I get a thumbs up quickly before I continue on? Can I get a thumbs up in chat? I really don't want to lose you guys along the way because this question would be a 6-mark question. So I just want to make sure that at every step, we are at 100% in terms of understanding. Okay, cool. Let's carry on. From here, we have to find the equation of the tangent at C. Let's do so. For the equation of the tangent at C, we're going to do the following. We're going to have y plus 2 is equals to negative 4 over 3. Remember, they have the same gradient. And in brackets, we have x plus 50 over 3. This equation that I'm using, I did show to you guys earlier in the session. I just want to quickly go up. We are using the, looks like the gradient point form. This one right here. So yeah, let's continue on. All right. So let's complete the equation. We end up with y is equal to minus 4 over 3 times x plus, oh, hold on. I didn't substitute incorrectly in this prior step. It's going to be, yeah, minus 14 for that one. You're substituting in this point into there. So yeah, I just didn't do it correctly. My apologies for that. But now that I've seen the error, let's continue on. We now end up with this as our equation. Cool. And now we want to actually get a final value for the range of t such that the line will cut the circle at 2 different points, not 1 or 0, but at 2 different points. So I'm just going to draw it one more time and show you guys exactly what I mean by that. Cool. So we start off at this point, right? We can all agree that it intercepts at origin. This is the line ON, right? Our line, our new line with the equation that we just found, if we move it up until its limit, which would be here at C or just before C, we can see that the y-intercept is also changing. So the y-intercept changes from 0 to whatever it is when it's over there. Ooh. If we look at the equation that we just found, that y-intercept that I refer to when doing that method or just showing you how exactly it's moving and shifting, or for the possible values of t, would be that 50 over 3. So the final value, or the final answer for this question in particular would be t is between 0 and 50 over 3. This 50 over 3 is just us shifting the y-axis, which subsequently shifts and adjusts this red line for the equation. Cool. How are you all? Sorry about that. How are we all feeling about this question now? Should I still explain again? Are we clear? This is a bit of a complex one, so I don't mind going over it one more time if I have to. Cool. I'm gonna explain again, but from which point? Are we all clear on how I got or why exactly I had to find point C and then the equation of the line that I'm circling in red over here? Are we all clear on how I got to that point and why exactly I needed to do all of that? Can I get a thumbs up, thumbs down? This is a 6-mark question. All right. I will just explain one more time because it seems as the majority of us, or a lot of us here, aren't able to see why we did what we did. All right. So let me just go over it again. We found C. Point C is the point directly opposite to N. We were interested in finding that because we know that for our line over here has to be between point N and point C in order for it to cut the circle at exactly 2 places. It cannot lie on point N and it cannot lie on point C because then would be tangents. Those would be tangents. And it only touched the circle at one point. So we are interested in finding the equation of a line between this range right here. Are we clear on that? Could I get a thumbs up? Are we clear on this so far? Cool. Now we want to find point C, right? Point C is a point, like I mentioned, directly across N. It's a diameter that's being formed now. From N to C is a diameter, it's a straight line. Point M is the midpoint of that straight line. And so we then use the adjusted midpoint formula. The regular midpoint formula is, let me write it in black. This is the midpoint formula. It's going to be the sum of 2 points, or the sum of the corresponding x and y points over 2. So it's going to be, let me write x1 plus x2 divided by 2. And then we have y1 plus y2 over 2. This is the midpoint formula. And we use this in order to get point C because, M is a midpoint between N and C. Are we all clear on that? Can I get a thumbs up or a thumbs down? Cool. We're all clear on that now. Now we have a point that we can work with. That is point C. Fine. We want to get the equation. So we want to get the equation of the line that is tangent at point C. And what we do know, what we can see is that the gradient of this line, the red line, will be the same gradient of line ON, and that is because they are parallel, because they're directly across. All right? And so that's how I ended up with this right here. For this, I used one of the equations that we briefly went over at the beginning of the session when we dealt with equations of a straight line. And this is the, I think, midpoint equation formula. I'm going to quickly scroll up to show you guys one more time. The gradient point form. There we go. So we use the gradient point formula. All right. And now let's get back to the question at hand. Cool. Now, using the gradient point formula and the point that we just found, which is point C, we get an equation for the tangent at C, right? At this point, we're almost done with the question. We next have to find the range of t values such that the line cuts the circle at 2 points. And that would be between 0 and 50/3. And that is because if we take our red line over here, right? If we start off there where it's like collinear with ON, then we see that the y-intercept is 0, right? But if we move the y-intercept up and up and up and up and up, we then end up with this right here. And we see that if we move our equation up by 50/3 units, we get to a tangent again. And that's how we're able to state that the range of values of t is between 0 and 50/3, but it's non-inclusive because they stated it cuts a circle at 2 different points. So how are we with this explanation now? Can I get a thumbs up? Are we clear on this? Are we 100%? If there's still any confusion? It is a bit of a tricky question. So yeah, I can see why it didn't click at first. But now that we've covered it in depth, hopefully we can now see how we arrive at the final answer. Somebody asked, why can't we say that t is between 8 and 50/3? We can't say that because if t was between 8 and 50/3, then you're essentially saying, just want to select this line so I can move it. You're essentially saying t is between all the way down here up until there. Because remember, we're comparing the y-intercept. How do we shift a straight line equation? We shift the straight line equation by moving it up and down. And that subsequently just shifted for our case over here. And so because here at the y-intercept is 0, we have one tangent. And at the y-intercept is 50/3, we have the second tangent. We know that it's going to be between these two values. We're going to be comparing the y-intercepts of the two values now. Somebody asked, where does the y plus 2 come from? It comes from the gradient point formula that we covered in the beginning of the session. So yeah, that's that. Hopefully we can move on now and just finish off this question and do 4.5. Right. Can I get a thumbs up if you can move on now? Are we cool? Are we fine with this question? Do we understand? All right, I'm seeing thumbs up, so I'm going to move on. I'm going to select this and just make it smaller so I have space to actually answer the following question. All right, 4.5. This is a 2-mark question. It asks, or it states, another circle with equation x minus 10 in brackets squared plus y minus 6 in brackets squared is equals to 25 is given. Will the two circles touch, cut, or not? We have to give a reason for our answer. So they've given us another equation for a circle. It has the same radius, 25. The square root of 25 is 5. And so they have the same radius, but they have different centers. The one center is M, which is, just gonna scroll up. Yeah, 10 minus 5. And the other one has a coordinate of minus 10 minus 6. We have to determine whether or not they will touch, cut, or not. How do you guys think we approach this one? We have 7 minutes left in the session. I want to give you guys maybe 3 minutes to think of a way that we can find out whether or not they will touch, cut, or not. And just drop your answers in the chat. Somebody said distance between the centers and check if it's bigger or equal to, if it's bigger, equal, or smaller than the radius. Yes, that is how we'd find out whether or not they touch, cut, or not. We're going to have to find the distance between the centers and get information based off that. And now with this new information that we've been equipped with, let's actually get an answer as to whether or not they will touch, cut, or not. So well done on spotting that. I'm going to check in about a minute. We'll review the answer in about a minute. But please, guys, try find the answer to 4.5. I'm not seeing many answers in the chat. Are we struggling with this one, guys? It's a 2-mark question, so it doesn't require much work. It just requires a deeper understanding of what we've actually done up until this point. All right, if there aren't any answers in the chat, I will just reveal the answer. They will not touch or cut at all. Oh, okay, yeah. So somebody just guessed at the last minute, they don't touch. Hopefully that was an informed guess and not you just throwing a random guess out. But yeah, they don't touch. And that's because our new, or our quote unquote, new circle equation is shifted up by so many units such that there's no possibility of them touching. We could simply just check the distance between the centers, find that value, and then get the sum of the radii and see and compare if there's any chance of touching, cutting, or overlapping. So I'm going to quickly do it for you right here in the last 3 minutes. Cool. So the sum of their radii is going to be 5 plus 5. Which is 10. Meaning that if they were to touch, or any yeah, if they were to touch, then the distance from the centers will be 10. Cool. The minimum distance between the centers, I guess we can say, is 0 if they lie at the same center point. And yeah, we know that anything between 10 or 0 and 10 means that they either cut, touch, or intercept or something like that. Now let's get the distance between the two centers. Let's use the distance formula, which is the square root of the difference between, or the square root of the sum of the difference between the corresponding x and y coordinates. The x coordinates, let's have 10 minus 10 plus, hold on. Let me check quickly if I'm writing down the equation properly. Yeah. I think I got my signs incorrect. So I did stumble a bit with that one. Cool. So it's going to be minus 10 instead of 10 minus 10. Yeah. Plus, now in here, we have minus 6 minus 5. This is then going to be equal to 11, but I'll do the working out for you over here. It's going to be, I think that one's going to be 20 minus 20 squared plus 1 squared. But yeah, anyways, we just know that if we do find the distance between the two centers, yeah, it's going to be 11, which is greater than 10. And so they do not touch or cut. But yeah, I was in a rush. You can do the math just to check and confirm yourself. But we are at the end of our session, guys. It's been a pleasure.